Welcome back, students. In this video, we're going to cover lesson 10.6. This is tangents and secants. So we're getting close to the end of circles here. All right, so a secant is any line or ray that intersects a circle in exactly two spots. Excuse me. So up until this point, we've been focusing on stuff inside the circle, a chord. But if it goes outside, if it goes through it, that's a secant. All right, so theorem. If two secants or chords intersect in the interior, so inside the circle, then the measure of each angle formed is 1/2 the sum of the angles intercepted by the angle and the vertical angle. So let me put that into some language you guys can understand a little better. All right, so angle 1 here. Again, excuse me, I'm sorry. Pollen is getting to me. All right, so angle 1, we're going to make it green. It's going to be 1/2 arcs AD plus BC. So you got to take half of it, or just add them and divide it by 2 is the way I like to do it, but that's the way they write that. Now, for angle 2 here, that would be AB plus DC or CB. I mean, CD or DC, however you want to say it. So, hold on 1 second. Yeah, sorry, my phone's telling me it's almost time for bed. So, anyway. So, inside the circle, add the arcs, divide by 2. We're going to see later that when it's outside the circle, like down here at the bottom, you're going to subtract the little one from the big one. But for here, add the 2, divide it by 2 when it's an angle inside the circle. So created from tangents and secants. Okay, to the right here. So if a secant and a tangent, so remember, tangent is, it only touches it once. Secant goes through it, so they would intersect here. Let's see, if they intersect at a point of tangency, so if they they'll cross right here, then the measure of each angle formed is exactly 1/2 of the measure of the arc intercepted. So let's do it this way. We'll say this is angle 1. Angle 1 is created from this angle, so it's this arc. So angle 1 is equal to 1/2 of arc AB. So if this arc, say, was 90, then angle 1 would be half of that. It would be 45. Angle 2, so it's created from, those two, and it makes this big old arc. I'll kind of do this so you can kind of see it. All right, so and it's going to be half of arc ACB, so that big old guy. If this big old guy here was, say, 280, well, that angle is half of that, so it would be 140. Okay, that makes sense? All right, let's go here. So theorems, or another theorem, I should say. So if two secants, a secant and a tangent, or two tangents, intersect in the exterior of a circle, so outside the circle, outside the circle, outside the circle, then the measure of the angle formed is 1/2 the difference of the measure of the intercepted arcs. So like I said up here, so let me just scoot them both. So inside the circle, we add and we take half of it. Outside the circle, we subtract the smaller from the bigger. So here you would say, so DE is going to be our bigger guy, DE, and we subtract it from BC, and that's the smaller guy. Over here, BC again, smaller guy, BC again, bigger guy, but you're taking half of the difference. And we'll do over here, so BC is your smaller, DBC, so this side is your bigger. So, but you subtract them. Subtract. It's the difference. So you're subtracting big from little, little from big. I word it wrong because I'm a math teacher. I know what all the symbols mean. I just have trouble saying them. So Inside means we add and divide by 2 or multiply by half. Outside means that we subtract and divide by 2. So let's get busy. This should be a very quick one. All right, so example 1, let's find the value of x. So we don't have to plug anything in. We're just going to find x and go on. All right, so we have, shows us that these two guys are congruent. Now, we learned, I want to say it was 10.3, it could have been 10.2, but if a chord is bisected by the diameter, then it's going to be perpendicular. So I'm just going to write right here, pretend like I'm a magician. I'm guessing that it's 90, okay? So let's do the math though. We found out that if the angle is inside, we add the two arcs and multiply by half or divide it by 2. I like to say, in this case, x is going to be, hate this pencil. X is going to be mn, that's arc mn, plus qp, that's arc qp. And I just like to do divided by 2. I mean, again, it's multiplied by half or divided by 2. This is just easier. So, mn is 117. This guy is 63. Divided by 2. So, 117 and 63, that makes 180. And by this, hopefully you know that half of 180, or 180 divided by 2, is 90. Because that's one of our little common things we do. And what was my guess? Ta-da! If we pay attention to the rules, we can catch some things. I understand there's a lot of them. I understand I've been teaching this 3 years. But if we listen just a little bit, I know I've caught some of you guys actually picking up on it, and I'm super proud, and I appreciate you guys. So, the practice, you're going to find x. So x is here. Remember, in the middle, we're going to add these two, divide by 2. Should be no problem for you professionals, all right? Let's go down here to example 2, and then we'll flip over, because there should be okay, there's not a practice 2, so we're going to do this one, then we're going to flip over, we can talk about a couple of things. We have a example 3, a practice 3, example 4, and then it says example 5, so I guess I'm going to just do the example 3, 4, and 5 for you. It'll be quick. It's just going to be a little bit messy algebra on the other side. This is where we touch into algebra 2 a little bit. All right, so photographer's taking a photo in the booth. In a boat. So he's sitting in this boat out here. He's taking a picture of this thing. His line of sights are tangent at point Q and point S. So his angle here is 36 degrees. What's the measure of arc QS? So we have the angle and we have one of the arcs. So what are we looking for? We're looking for QS. All right, so QS is a minor arc. So this is a major arc. This is our, what are we going to do? Well, actually, it doesn't give us either one. It just gives us his angle. So we know that the major arc, so major arc, actually, so yeah, minus the minor arc. Hold on, how did I write this? No. Let me just do this, hold on. Hopefully you're using a pencil. So the major arc is the same as 360 minus the minor arc. Okay. Arc. All right, let me just get over just here. That's the end of the page anyway. All right, so that's important. So this big thing's 360. This guy here is 360 minus this guy. That's important because we're going to mess with this formula. All right, so we know that the angle is the big guy minus the little guy divided by 2, right? So it's big one, QRS, minus, so QRS, minus QS divided by 2. All right, and we know that angle P is 36 degrees. Why? Because it told us. We're going to multiply both sides by 2. So these will cancel. So I'm going to equals. I'm not even going to write this because 2 goes into 2 one time, so our fraction disappears. But we are going to multiply 36 by 2 and make it 72 right underneath. All right, so this will give me space. So QRS minus QS equals 72. We're working in between. How did I do this? And so yeah. So we know that. So this is QRS, and we know that we can exchange it for 360 minus QR. Okay, so if we can replace this with this, so we're going to replace this with this. Watch me. Watch me. Watch me. There's your bonus word. Watch me. Extra bonus if you tell me who the group is without having to Google or whatever. So it's supposed to be QS, not QR. It's QS, QS. Not QR, not QR. Not the mama. Okay. So we're replacing this, my goodness, with QS. Okay. And now we got to write this. So 360 minus QS is the same as QRS. So QRS equals 360 minus QS. And now we have another minus QS because it because the angle equals this minus this divided by 2. All right, so we multiplied both sides by 2. So 36 times 2 gave us 72. All right, so now we have 360 minus QS because we replaced this with this, and then it still had that. So that's the same as 360 minus 2QS, okay? Stay with me. All right, so 360, I'm going to subtract 360 from both sides. I know. Mr. Whitlock, what are you doing with these negative numbers? Just hang with me. So positive 72 minus 360, and let me just scooch a little, is going to give us negative 288. And it equals negative 2QS because that was over here. Divide both sides by negative 2. Divide both sides by negative 2. See, negatives are going to cancel. We're going to move up here. These guys cancel. So QS, that's what it asked for, right? It's going to equal negative 288 divided by negative 2. So the negatives cancel. 288 divided by 2 is 144. So QS is 144 degrees. That means this guy is 360 minus 144. All right, flip it over. Gotta hurry. It's late and I get in trouble for being up late past my bedtime. All right, backside of page 10.6, we got two theorems, a practice, and an example and a practice, and 2 more examples. So let's just try to be as quick as we can. All right, up here, so theorem. So if 2 chords intersect in a circle, then the products of their lengths of the chords are equal. So it's like AB times BC. So you're multiplying the sections. I can't say halves because they're not halves. They're pieces. So don't mess that up. But you'll probably hear me mess it up. So just be prepared. Actually, we've done this, but we'll probably talk about it again in the review. So it'll be green times, that's like, what the heck is that? I guess pink. I can't see. But these 2 are going to equal these 2 multiplied together. All right, over here. So if 2 secants intersect in the exterior of a circle, so it's out here, then the product of the measures of one secant segment and the external secant segment is equal to the product of the measure of the other secant segment and its external secant. So just hold on. So EC, or yeah, CE times DE. So all the way. So it's the outside times the a whole thing, and then the other side it's BE, I'll go under it again this time, times AE, which is it's going to be from all the way. So hopefully you can see that, but you'll see it down here. So on 3's going to be the easier one. Then it gets a little tougher from there. All right, so example 3. Find PT. So PT here is 2 times x plus 2, and then we'll plug it in, and go for it right here. So PT, so it's this time it's a section times a section, section times a section. So here it's PT times TR, because these are inside. So and then ST times TQ. So let's just fill in. So 2x plus 2, and that's 5, equals ST is 5 plus, I'm going to write these backwards. This is 6, and then out here it's going to be x plus 5. And I'm doing that for a reason. It doesn't matter, it's the products. So it doesn't matter how you multiply them as long as you multiply them, but I'm doing this for a reason, so I can make sure you guys don't forget about the distributed property. So we're going to do this side first. So 6 times it's x plus 5. So you can't just say, well, that's 6x. No. 6 times x is 6x. 6 times positive 5 is positive 30. All right, over here, just because it's written that way, it's the same as this. So it's 5 times 2x. So 5 times 2x is 10x. And then 5 times 2 is positive 10. Okay? Now, let's continue business as usual to solve for x. So the 6x is smaller. These cancel. 6x times 4x, I'm sorry, 10x minus 6x, good lord, I get, equals 4x. 10x minus 6x equals 4x. The plus 10 comes down. These guys are canceled. We got 30. So we're going to subtract 10. Subtract 10. I'm going to move over here sideways. So we got 4x equals 30 minus 10, which is 20. Now we got to divide both sides by 4. So x equals 20 divided by 4, which is 5. And then we're going to plug the 5 in over here, because we've got to find PT. PT is 2x plus 2. So 2 times x is 10. Look at that. 2 times 5 is 2 times x, or 2 times 5, good lord, is 10. 10 plus 2 is 12. So PT is 12. They don't give us measures, so we're just going to say 12. All right, find QR. So you guys are going to do the same. Multiply this times this times this. Put them equal to each other. Solve for x and plug it in. Have any questions, let me know. All right, scooting to the bottom. This is the end of 10.6, I believe. Yes, and then 10.7 will be the last video for the module 7. It'll be the equations of circles, and then I'll do one on the actual study guide. We'll do that in class tomorrow. Had quite a few of you turn them in. You like the extra credit for turning in early, and I like to see the work early because I can correct things before the test, which is something I can't do during the test. So, works for everybody. All right, I'm just coloring in some stuff here because this is how we're going to multiply it. Because remember, it's the outside portion times the whole thing. The outside portion times the whole thing. So it's going to be AB times AC equals AE times AD. Now, we're going to have to scooch a little bit because we're going to have to play with this. You're going to do the same here. It's going to be this times this, the whole thing. And then, but you have less digits and stuff. I have this to work with. That's okay. We're going to make it happen. So AB is easy. That's x times 2. AC, so I want you to notice. So AC is, let's watch this. AC equals AB plus BC. Because folks are like, they get this confused. All right, so AB is x plus 2 plus, what is BC? BC is 8. All right, combine like terms. I only have one x, but 8 plus 2 is 10. So AC is x plus 10. All right, so AE, that's easy, that's x. AD, so AD equals AE plus EC. ED. So, and if you ever get confused, you're like, wait a minute, I can't figure out heads for tails. Remember the segment addition postulate. This plus this equals the whole thing. Just like I like to use the dry erase markers at school. They fit together, and one of them plus another one. And when you're talking about being congruent, well, all the markers are the same. When we're not, then we have to remind you guys of that. But anyway, all right. So AE, that equals x, plus ED is x plus 8. Combine like terms, so I have an x and an x. Well, I have two. I have two of them, so that's 2x, and that plus 8 goes along for the ride. So AD is 2x plus 8. All right, so distributive property on the right, it'll be that for both, but we're going to have to FOIL this guy. All right, so x times 2x. X times 2x is 2x squared plus x times 8 is 8x. All right, over here. Now I'm going to let's do this. I'm going to do this guy down here. It's x plus 2 times x plus 10. Gives us some more room. So our first is x and x. X times x is x squared. Then you have 2 times x, which is 2x. Then you have 10 times x, which is 10x. And then you have 10 times 2. And they're both positive, so it's positive 20. We can still see, so we have x squared. 2x and 10x make 12x, and then we still have plus 20. So we're replacing that up here. If you have trouble with polynomials, please come see me. Love to help you out. I know, I know those are a big deal as far as that Algebra 1 EOC. All right, so now this is what's left after the dust clears. X squared plus 12x plus 20 equals 2x squared plus 8x. Don't get scared of this. So like terms. This one's bigger than that, so subtract the x squared. So it's not going to cancel out like it did before. That's okay. It cancels here. We got 12x plus 20. So 2x squared minus x squared still leaves an x squared. And then we have an 8x. All right, so let's try to put everybody together. Let's just subtract the 12x from both sides. So these are canceled. And then over here, so I'm just going to start scooting this over. So x squared. So 8x minus 12x. So we have a negative 4x. And then the 20 is going to have to come over too. So we're just going to subtract 20 and then subtract 20. So it'll be minus 20 equals 0. And it's because we're going to hang on, factor that out. And let me just check something real quick. I had 12x. Yeah, negative 4. Well, okay. Anyway, so now we have x squared minus 4x minus 20 equals 0. So we're going to have to factor this guy. So x times x gives you x squared. All right, so what two numbers added together or multiplied together give you 20, but added or subtracted give you 4? Well, 5 and 4 would give you 20, but that's not going to give you a 4. Let's see, 20 times 1, that's 19. Nope, not going to work. What are our factors of 20? Let's write it over here. So 20. So you got obviously 20 and 1. We've already done that one. We got 4 and 5 or 5 and 4. What else do we have? I think that's it. So what did I do wrong? Let me go back up here. Alright, so x squared, 2x, 10x, that's 12x, and then that makes 20. All that looks right. 2x squared. Alright, wait a minute. Wait. Okay, here's my problem. This is x. It's x times... Where did I even get all this mess? Oh, 2x plus 4, not 8, though. I'm sorry, guys. I'm sorry. It's very late. So, yeah, I knew this was, like, not looking right, man. So, this makes, instead of that, it makes 8. So, these I can deal with. So, 5 times 4, that's still not right. What's the deal? Oh, but 10 times 2 makes 20, and 10... negative 10 and positive 2 make that. So negative 10, positive 2. So that would be 2x minus 10x. So that's negative. And then positive and negative make that. So that means x equals negative 2 or x equals 10. All right, so we can't have a negative... can't have a negative measure. Now, if we put this in here, what are we looking for? We're looking for AB. AB was x plus 2. Well, so x plus 2, if x is 2, that's 0. You can't measure 0, so we can't go with that. So x has to equal 10. And if it equals 10, so AB equals x plus 2. That's 10 plus 2, so AB equals 12. All right, gotta make this, this one quick. I was thinking you guys were gonna do that, but I forgot it's me. So it's the outside the circle times the whole guy times goodness, not enough colors, and the whole guy. So it ends up being MN times MP equals MQ times MR. All right, we'll go into the red so we can kind of get away from that. All right, so MN is 3. MP, so that's 3 plus 4. 3 plus 4, so MN is 7. MQ is 2, and this is 2 plus x, or x plus 2. All right, distribute, so 3 times 7 is 21. 2 times x is 2x. 2 times 2, both of them positive, is 4. Subtract 4. I'm going to switch to this guy. Subtract 4, subtract 4. These cancel. 21 minus 4 is 17. That equals 2x. Divide both sides by 2. And x equals 8.5. And they asked what QR. Well, QR is x, so that would be 8.5. All right, guys. Tomorrow night I will do the video on the equations of circles and the study guide. If you have any questions, again, send me a message on Focus, send me a message on Teams, or comment to the video. Please consider liking and subscribing. It helps get the channel out there, and I'd like to help as many people as I can. Until next time, have a good night.